Hello everyone, let's talk about another easy problem on Leetcode today. Sum of left leaves, Leetcode 404. Um, Ideally, it should have been Leetcode 404 not found, but actually it is sum of left leaves. But it's up to Leetcode. It states that given the root of a binary tree, return the sum of all left leaves. A leaf is a node with no children. A left leaf is a leaf that is left child of another node. Now let's jump into the example. In the first example, we can see that the tree given is with the parent node 3. Then we have 9 and 20 as children, and then for 20, 15, and 17 are the children. Um, and the main left leaves are 9 and 15, right? And the sum of these will be equal to 24. And that is what we are looking for. Now that we have understood the problem, let's jump into the solution space. Uh, wha- there are multiple ways to solve this problem. One way can be that we can do the pre-order traversal. So the simple idea is that at each, so pre-order traversal means first focusing on the parent and then focusing on the children. So what we will do is like at each point or at each node, we will check if we have the left child. If yes, we will add it to the sum. Otherwise, what we will do is like we will, in rest of the cases, we will be just processing the rest of the tree, trying to find the left leaf and then just add it to the sum. I think it will become more clear with the example. So suppose we have this tree from the this example we had earlier. So we will start with the root node 3. We process it in the sense that we will see if we have a left child of the tree which is also a leaf node, and in this case the answer is yes. So we will add it to the sum, and then what we will be doing is we will be processing rest of the tree. So suppose if it had more, I think because it's a left tree, left leaf, we are done here. But in this case, we still have this side remaining where we can find this potential node 15. So what we will do is like we will add some of the left leaves 20. And again, now when 20 is the next node, what we will do is we again check if do we have what you say a left leaf node or left leaf child from 20, and the answer is yes, 15. So we will just add it to the answer, and since nothing is remaining in the tree anymore, we will just return. Let's look at one more example. Suppose 15 was not a child of 20. So in this case, what we will be doing is like we will be going to node 7. And there we will be, in this case, we will find no left leaf child, but still the tree will be done. And we will just return 0 in this case because we that will be basically be our base case, and our answer will be 9 in this case. So depending on how the example looks, I think this is the only thing matters to us is like whether the subtree or the tree has a left leaf node. If yes, add it to the sum. Otherwise, just return the value appropriately. Another approach which we can take is we can do a BFS of this node, BFS on this tree. So what we will do is like at each level, we will be checking where are we going. Are we going left or are we going right? This is important because if we go left, that means the element is a child. That means that adds up to the sum. So let's look at the example here. So suppose we are at 3, and we will add it to the queue because BFS or label order traversal does use the queue. And what we will be also as adding is like, are we coming from left? And the answer is no, because this is a parent node. Then what we will be doing is like we dequeue 3, and then we see it has two child, 9 and 20, right? Now we will enqueue them, but for 9 we will enter this as true because we are coming from left, and for 20 we will enqueue false because we are coming from right. uh, once we do this, we see if now we again dequeue 9, and we see, oh, it does not have any left or right child, and also we are coming from left, so we will add it to the sum here. And now we will also dequeue 20, and now and but we see it's false. The value for it, like is left, is false. In this case, what we will be doing is like we will then enqueue 15 and 20 to the queue. For 15, we will add left is coming from left as true, but for 20 we will add false. Again, we dequeue q, and we get the value 15, and for this we see that okay, it does not have left and right child, so we have nothing to enqueue anymore. But it's a child, and it is a left child because is coming from left is true, and that will then we will again add it to the 9 here, which we had previously. And similarly, we will be dequeuing 20, but we are coming from right, even though it's a left and right child, so we will not enqueue anymore, and that will be our answer. So both the approaches are good. If we compare both of them, I think first one is like recursive and second one is iterative. Of course, you can use stack to make the first one also iterative. Second thing is like the time complexity is O of n. And I will be writing the first solution because I like recursive solutions more. It's like very simple, and once you understand the concept, it's very easy to write, and the code is very succinct in this case. So let's now jump into the coding space. Now that we have understood the concept, we can easily code this problem. So I think I'll be just solving it for the pre-order algorithm that we discussed earlier. So first thing we have to do is like we have to just look at the base case, right? So for us, the base case is if the root is null, that means we don't have any left or right child. So in this case, we can't get any sum at all from the tree. So we will just return 0. Else, what we will be doing is like we will be just checking if root dot left is not equal to null. That means that we do have a left side of the tree, and root dot left is equal to null, and root dot left dot right is equal to null. So basically we are saying is like if root dot left is not null, but it's a child, it's a leaf node, that means root dot left 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 side's root left side's left pointer is null, and left side's right pointer is null. That means that is our answer. So what we will do in this case is we will just return root dot left dot value plus sum of mainly this recall this function, but this time we will just call it for root dot right. So this is one thing. Then what we will do is like if that's not the case, right? Notice that I'm returning the value because that's what I care about. But if we couldn't find the left node which is also a leaf, we should still process rest of the tree, right? Because it may be a very deep tree. Like just not look at this example, but it may be a very deep tree, and we have to still process them. So in that case, the problem becomes simple. So we will again return, but this time we will just return sum of left leaves for root dot left plus sum of left leaves for root dot right. And that's it. I think so either of the for either of the cases, we will just process and get our answer. So let's submit this code. Voila, so it actually works, and I hope the solution was useful to you. And if you really like this content, please do subscribe. Thank you again. Have a nice day.